Hello. Hi, all. Uh, yeah, today's session we have Vinothini Raju with us. Vinothini Raju is a CEO and founder of GoPaddle, uh, a company that has been at the forefront of local DevOps transformation. Over the last 20 years, Raju has had the honor of working with some of the top influencers in the DevOps space. She has seen the evolution of Kubernetes and platform firsthand, living through the chaos and contributing to its future. So today's session, like I'm also like a part of Go Paddle team also. So today's session, I'm joining with Vinodini, and we are talking about platform engineering and some of the developer platform engineering, sorry, internal developer platform tools. Welcome, Vinodini. Uh, yeah. Uh, Vinodini, okay. Yeah, let's start it.
Awesome. So I see a few people have already joined the call. So should we wait for a few more minutes before we get started, or shall we start in any way? People will join. Maybe, what do you think? Maybe another 2, 3 minutes? We'll start around 12:5, and then another 2 minutes.
Yeah, sure. Yeah, maybe we can start 9:35 or
Yep.
okay.
Yeah. So maybe we can take this time to quickly have an idea about the type of background. I see a few people who have already joined, so I just want to understand the type of the background, the experience you folks have on the DevOps and the platform side. So since we cannot add any apps, I was trying a few poll applications in Zoom, but looks like all of those require some subscription. So maybe we can just use the chat room for any communication. So I'd like to know how many of you are already working on DevOps automation or a part of a platform engineering team. You can just say yes if you belong to a platform team, or you can just type in a no, so that we know like what kind of a background you have. Okay. So this is going to be a fresh start, and I'm hoping that whatever we are covering today is going to be useful. Even if you have been working on any DevOps tool chains already, still I think you will find this presentation useful. Yeah, so for those of you who have joined a few minutes ago, if you could just type in saying if you had uh, DevOps or platform engineering experience, you can type in yes or no. Okay. Okay, so I see some of you have some experience in this space. Um, how about specifically on platform engineering? Are you a part of a platform engineering team? Would you be able to type in a platform if you are a part of a platform engineering team? Can you type in platform if at all you are a part of an platform engineering team? The reason I'm asking is because it could get a little broad because it has too many things to cover. So I can actually present the session based on whether you have some experience already. Anybody who has been a part of platform engineering team can type in platform. So looks like we don't have anyone who has such kind of an experience, so that's fine. Okay, so this is going to be around 2 to 3 hours of interaction. During the session, you can stop me in between, you can ask me questions. Please feel free to, put in your messages in the chat room. So in between the session, during the breakouts, I can definitely, I can answer those questions and we can have more interactive session. Okay, so let's get started. Yeah, so today's session, we are going to cover two main things. One is internal developer platform and platform engineering. And of late in this DevOps space, you must be hearing a lot about these two emerging technologies or the concepts. And if you are in the DevOps or if you are planning to get into the DevOps space, it's really important to know what is this new thing all about and how it fits into the whole DevOps space, right? So I'm going to be talking mostly on two specific tools, but however that covers an internal developer platform and the platform engineering overall, right? So this is about us. So Gayathri has given a quick intro. So Gayathri is a part of Go-Paddle team. She has done a quick intro about herself. She's also the co-organizer of the KCD Chennai. Myself, I'm the CEO at GoPaddle.io, which is the next gen cloud native platform. So we'll talk about it in a while. So what I'm planning on covering is broadly one, we'll start with an intro to IDP and the platform engineering. So we'll see what are the challenges and what led to IDP and how is it different from a platform engineering. So the basic concepts of these two. Then we'll have a breakout for 10 minutes. And then we'll have a deep dive into two specific tools. And then on the third part, we will have a demo and a use case. And fourth, we will do a hands-on. So this is going to take at least 2 to 3 hours broadly. But if you want to structure this differently, please feel free to let me know in the chat. And maybe towards the end of part one, we can look at restructuring it if we can, right? And throughout the session, for all those subscribers, we are giving a discount coupon of $150 worth of a coupon to our GoPaddle Lite edition. And that is a 3-month subscription to our Lite platform. And you can avail this or redeem this before 15th of July, and you'll get 3 months free subscription, right? And this is like unlocking your multi-cloud capabilities and CI/CD automation and many other capabilities, which we'll be talking about in a while. But you will be getting a $150 worth of a free discount. And towards the end of the session, there is going to be a hands-on. And if you are able to, solve a problem, build a CI/CD pipeline, one, you're yourself learning how to do it. And if you are successfully being able to deploy and showcase an end-to-end use case, we are also offering another $500 worth of a discount coupon. And you'll be featured in one of our blog posts and in the social media promotions as well. Okay, so this is a perk for being interactive in the session and also learning what it takes to build a complete platform. Okay, and that's about the intro. Now let's move on to the session itself. Let's talk about the IDP and platform engineering first, right? So we need to understand what these two mean, and then we will explore the tools later. So for us to understand and appreciate what these mean, we need to understand how DevOps itself evolved over a period of time. And where it started was the first thing, the concept of just-in-time emerged in 1948, where there was a lot of focus on production efficiency. It was mainly on the machinery side when Toyota was trying to bring in efficiency in their production systems, right? So they want to cut down on overburden, inconsistency, and reduce waste. So, which means, there was a process automation, cutting down on the waste, and inconsistencies can be achieved, can be reduced through continuous feedback loops. So the DevOps itself has borrowed a lot of concepts from this. So the just-in-time was the first starting point towards the whole evolution. And in 2000, Agile Manifesto was primarily focused on software development process automation, right? So Agile can still can work with DevOps. It is just a form of a process for software development, right? Today, different processes are still Kanban-based deployments are still the software processes are all there, but Agile was the starting point for the process automation from the software development perspective. Then came the cloud when AWS pioneered the the infrastructure as code, where it was enabling the developers to build innovative applications quickly by abstracting away the infrastructure components. Then came the microservice, so where ThoughtWorks again was the pioneer here. They started, moving or coming up with the concept of building smaller workloads and packaging and deploying them as smaller chunks of services compared to the service-oriented architectures. So this is the next move towards the architectural transformation. In 2006 came, build it, you run it. Now this is the philosophy. Now this was actually expecting more from the developers from owning their own deployments. Okay, this came from Werner Vogels, and this was a sort of a precursor to what became the DevOps when Patrick Debois, who was an engineer who was working for a Belgium government project, and there it was not one single developer who was owning the deployment. It was a group of developers and operations team. And anything that developers have to deploy, there was a friction between the developers and the IT teams. And he was trying to put some confidence around this concept of why they should work together. And that's how he named the conference name itself was named as DevOps Days, because he wanted to bring dev and ops together. So that's how the DevOps term was coined by Patrick Debois. And then that actually talked about shared ownership and how you can automate the workflows and have a rapid feedback between the dev and the ops team. Now that became the DevOps philosophy, right? So it's not about tools, it's about the cultural transformation and the coordination between the dev and the ops teams to deliver things much faster. Now, how we do that could actually be, derived from some of the previous transformations on how do you architect your applications, how do you reduce waste, how do you improve your software development process. So it could actually borrow concepts from all of these in order to achieve the end goal of how can you deliver faster through automation. So that's how DevOps came into picture. Now, after this came the SRE. Now you have deployed something. Now, how do I maintain the service level objectivity, right? How can I keep my services up and running 24/7? So Google has been following some SRE practices in-house. They built a system called Borg, which became Kubernetes, which they open sourced and they named it as Kubernetes later on, right? And 2007-8 is when the platform as a service evolved. Now, platforms became a thing because Heroku could say, okay, you take your application in one command, you can actually deploy. and it was using AWS as the underlying cloud platform. So it was all totally seamless for the developers. All they have to worry about is to just focus on their own application, right? And Docker came, Kubernetes came, and now what happened? This is what happened. So we saw like, okay, I'm assuming like you are aware of Docker and Kubernetes. So Docker standardized the application packaging, Kubernetes standardized your environments, right? So this is what happened. So far, the number of tools around 2011 or 12, the number of tools that the DevOps engineers used to deal with were just for very few countable ones. Say, for instance, Puppet, Chef, Ansible, right? And that was complex too. But now, if we look at it, there are thousands of open source CNCF projects itself, right? And it's pretty overwhelming for somebody to start building a DevOps automation for their company or enterprise. So this is pretty overwhelming. And what that means is that it cannot scale for many reasons. It's not just about the tool chain. It is also about how it is being adopted. Let's look at each one of these phases in the adoption, right? So first one is on the application configuration itself, right? So it's the moment we bring in microservices and the moment we bring in different types of infrastructures, right? And when we try to scale this whole thing, what happens is that the dependency management between these microservices and how these dependencies and these microservices are version controlled, these changes are version controlled, and whether you can reuse some of those microservices and whether these microservices are portable. All of these aspects become questionable. Okay, for instance, let's take an example of a Swiggy like a platform, right? So they may have around 200 to 300 microservices. Now, each one of these servers can have interdependencies between these, right? One change in one of the service can actually break other services that are dependent on those, right? Similarly, all of these microservices now are to be deployed in a way through, say, in the form of YAML files on Kubernetes, right? Now, a user changes the configuration of the YAML files, and how can somebody know what has really changed in that YAML file? So now GitOps is one philosophy that is being used to version control and track these YAML files to know like this is the deployment change that has gone in, right? But when the number of services and the number of Git branches increase, this configuration versioning also becomes a lot more difficult. And out of these 200, 300 services that we have, suppose if one of the service has to be reused, for instance, a database, okay? If the database MongoDB service, if there is a license associated with it, and the company has to purchase the license, and now this has to be reused across different teams and different subdivisions within the organization. Now, if it is not being reused, then each of the team is going to build their own database, and the procurement and maintainability of these services become difficult. So we need a catalog of services which the rest of the teams can actually go and reuse it. And they have to do it in such a way that they can do it by themselves, which is the self-service aspect of it. And the last part about the portability, right? So if a developer is building a service, how can that service be reused across different environments? So which means you'll have to pull out some of the configurations outside the application, such a way that the same application or the same images or the artifact can be deployed on, say, production, staging, or QA environment by just changing the configuration alone. So how you configure your application, how you manage the dependencies, and how do you version control all of this becomes a lot more difficult the moment start scaling the number of services. Next comes the infrastructure orchestration. This is about, the enterprise or the company uses multiple different tools and subscriptions. For instance, there is a GitHub subscription, there is a cloud subscription, there is a different PagerDuty or any other tools for alerting, logging subscription, cloud subscription, and image registries. It may come from different platform, either from Docker Hub or other cloud registries, right? So somewhere we'll have to maintain all these subscription information in a central location so that we know how it is being used, and it's easier to put controls over those different subscriptions as well. The third aspect is about the environments. We are talking about Kubernetes environments. So now the moment it scales, again, use as developers, if they have to go and provision and manage those environments, there is a steep learning curve of knowing a lot about the Kubernetes, and that actually impacts the productivity. So even if they had to provision, they need to have a systems knowledge to do that. They need to understand the cloud and other infrastructure before they can go and provision these environments. Next, about the deployment management. This is about building the CI/CD pipelines. Again, this becomes more difficult when you have to have a lot of workflows and integrations with other tools. And finally, there is no separation of concern. So who owns the YAML file? Even if you actually look at a Kubernetes YAML file, there are sections where there are developer-specific configurations where they have to say, this is the application that we want to deploy. There are storage-specific definitions, which usually are maintained by storage admins. There are infrastructure and provisioning capacity requirements, which are usually done through other IT administrators. So there is no separation of concerns or the separation of responsibilities when they have to deploy through Kubernetes. So let's take this again. Some of these charts are available on the internal developer platform.org. You can also go learn about it from this website too. So if you actually see on the left-hand side, this is a survey done, I think, a couple of years ago. It's not the latest. I think around 2020 or 2019 is when this survey was run, and you could see that developers and architects who were working on cloud native transformation, they felt extremely burnt out, and they really wanted to switch their roles, move out of the jobs, and it actually caused a lot of stress, right? And the second one is again from another survey report. Unfortunately, I have not linked those sources here. But this is again from another survey, which actually says that developer productivity is related to the technical debt. The technical debt is something that comes when things are not done the right way, right? If the automation is done in an ad hoc way, by just you get a requirement, so somebody asks, okay, go introduce a new monitoring tool. So randomly some tool has been introduced without consideration for the entire org-wide requirements. Then over a period of time, maintaining those integrations becomes a lot more difficult, right? So just because something is again available readily and easily, if you bring in that tool, it becomes a lot more difficult, or the maintenance becomes difficult over a period of time. So that in turn adds to the technical debt. So the maintenance becomes a challenge, right? If you actually look at this table on the right-hand side, this is overall time and the frequency of deployment for each of these categories, how long it took for the developers, and what really added to inefficiency, right? So the major blocks, if you actually see, is about managing the services and their dependencies. It took a lot of time. And then comes the environment provisioning, right? The environment provisioning, spinning up an environment took 24 hours, right? And they had to wait until somebody provisions that environment for them. So this is a lot of time, and onboarding new developers and ramping up on the technologies is another big chunk. So how do we kind of make these uh, issues go away, right? So these issues have a direct impact on the business, right? So the developers, as per one of the Stripe survey, developers spend about 13.5 hours every week on the technical debt, and that costs a lot of money for the businesses. And that in turn also impacts the developer productivity, team morale, and the innovation. So this ad hoc implementation and the complexity adds to a lot of inefficiencies for the businesses, right? So they had to developers had to repeatedly solve issues in Kubernetes environments, and they had too many integrations and dependencies to manage. And if they had to introduce a new feature, it becomes, especially to the platform itself, is very extensibility of the platform itself is very difficult. So there comes the the internal developer platform having understood the problems, right? So now there is a developer centric platform which will help solve all these issues, right? So this internal developer platform, as the name suggests, it is an internal platform. It is not something that is publicly announced to the rest of the world. It is something that is specific to an organization or a small team within the organization, and it is focused on the developer, and it is a platform, right? The platform here, it means it's a product that the team or somebody from their operations team would bring up, configure, and give it as a platform to the rest of the developers. So the key aspects to consider here are the first one, there is a platform team, right? So it's not a DevOps team. DevOps team is different from a platform team. So the platform team is the one which builds the portals for the rest of the team. A DevOps team, whereas a DevOps team, if you actually see, they do the automation. And that automation cannot be scaled to a larger organization. Whereas a platform team is central to the organization. They start, kind of work towards building a centralized platform, and it is for across the organization. And in the case of internal developer platform, the platform team builds a platform for the developers very specifically. And by providing this platform, they make sure that there is a golden path. So what does a golden path mean? It gives a guided approach so that developers do not make mistakes and they have a standardized way of onboarding applications, right? So if the platform team provides a template on how to onboard an application, so every developer will follow the template of onboarding those applications onto the platform, and the developer's responsibilities stops there. So they don't have to worry anything about the infrastructure components at all, right? And it is a self-service in the sense they don't have to wait for the operations team to go provision environment, so that platform team, I mean the developer platform itself would abstract away all those complexities. And it is also a host of many tools and technologies. So you can have multiple tools built into the internal developer platform itself, and that reduces the cognitive load on developers. This is a definition again from the internal developer platform.org. You can go look up. So this is again an initiative to bring in more clarity around internal developer platforms and platform engineering. So this is a definition from this particular website. So what I'm trying to say is that the whole idea is to reduce the burden on the developers. So it brings in more standardization, it automates workflows, and you can set SLAs and maintenance and everything. Now, whether this is suitable for your organization or not depends upon the size of the organization. Now, let us quickly go over the board and find out, like, is there anybody from the group whose team size is beyond, say, 10 developers, 10, 15 developers? You can probably raise your hand just to see whether if there is somebody here who's working for a larger team. Okay, looks like no one. Okay, yeah, so that's awesome. So yes, so will DevOps be sufficient in that case? Over a period of time, it can become overwhelming. For a smaller team, a developer platform or a platform engineering can be overwhelming. So there is we'll have to see a balance between these two. So for larger teams, platform developer platforms and platform engineering is extremely useful in the long run. Now, having seen what the IDPs are, let's see what's the difference between IDP and a platform engineer, right? So platform engineering is, as you can see, it is a single source of truth for the entire organization. It is not just focused on the developers. So you can see the application, it provides application onboarding. It helps sets the service level objectives for a service team. There is an option for the IT to go provision the infrastructure. So it acts as a centralized governance platform for multiple teams to communicate, coordinate, and ensure that the business, all the business as a product lifecycle is managed, right? So there could be multiple pockets of DevOps who have been automating this. Now with the DevOps as a platform engineering, all the DevOps automation will be centralized. So it kind of standardizes all the DevOps practices. And that by doing that, it is going to reduce the friction between the teams because everybody can communicate on the same page, and it also increases the developer experience, right? It also increases the productivity. So this is the difference. If you actually see, the developer platforms are specifically focused on developers, whereas the platform engineering is across the board. Okay, now building a platform in-house is equivalent to systems engineering. So systems engineering usually refers to building an aircraft, right? So some of the entities you see on the right side, these are some of the entities: accessibility, accountability, adaptability, and agility, scalability, reliability. All of these entities are a part of systems engineering. Why is it so important? Because these are about scale, right? So you need to bring in all these, say, durability, degradability. You can see all of these abilities are important if you are building a large scale system that is supposed to be highly available. So Kubernetes itself is sort of systems engineering because it is distributed and it has to scale and it has to be reliable, right? All those, and it has to be resilient. It has to be repeatable, right? So anything you build on top of it, it's sort of a systems engineering. So building a platform that abstracts away all these abilities is going to be very, very hard, right? And even if some of those aspects are figured out, what may become difficult is how do you extend this in future, and this abstraction and extensibility becomes a pretty hard subject in terms of platform engineering. The reason being, the applications that these platforms are going to host are going to be numerous, right? Say for Java, it may be one set of the one way of onboarding and building and deploying, whereas a Golang or a Ruby or a Python may be very different, right? So similarly, when it comes to the infrastructure, again, it has to abstract. So it has to abstract all the cloud platforms, the hybrid environments across on-premise and cloud. So balancing these abstractions between different components is the hardest part, right? And a lot of system thinking is required for that. And the next thing is, somebody who is building, the team who is building this, they have to be up to date on the tools and the ecosystem. And as I said, every single day there is some new tool getting announced in the CNC of community, and or constantly, those integrations have to be looked at. Then new announcements for, say, suppose the tool is integrating with 30 or 40 plus tool other third-party tools. Any upgrades in those tools, the platform has to be upgraded and it has to be maintained. So it is a product development itself within the organization, and the organization has to put a dedicated investment in building such a platform, and it will have its own product life cycle, right? So that is the second challenging aspect. Now, after having built that, or while building that, that needs an org-wide adoption. So what's the point of building something which the developers are not using? So there must be some way of enforcing or working with the developers, gathering their requirements and making sure that it's being adopted org-wide. Now, the success of such a platform depends on whether everybody within the organization is using that platform. If there are small pockets of teams who are not adopting that, then the whole purpose is lost, because there is again a siloed version of automation. So what's important is to make sure that there is an org-wide adoption of that platform. And this requires dedicated investments, as I said, for a long-term strategy of building this platform. And then we also have to have a 10x team with a multidisciplinary or polyglot team, which can integrate multiple different tools together. Now, this, if you actually look at it, it's pretty overwhelming. So we did a small survey, still a small surveys around 75 plus platform engineers, DevOps, and some of the head of engineering teams have participated in that across the globe. And this is what they saw as the platform engineering hurdles. As I mentioned earlier, org-wide adoption is first. That is the top. That is actually topping all the out of all the barriers. That's the first thing. Sorry. The next comes the ad hoc implementation. As I said, like you see a tool, you bring in, but whether it is really needed and whether it is implemented the right way. The maintenance becomes the next challenging aspect. Too many requirements to handle, and even after building all that, scaling that is a lot more difficult. So it's just in the priority. So just to show you that I'm not talking out of the blue. So there is a survey that we did, and this is what we got as a feedback from around 75 plus DevOps engineers, platform engineers, and people who are heading the engineering and the platform engineering initiatives. Okay, so I'm going to stop here. This comes to the end of first section. We have spent around 30 minutes on this. Any questions so far on this, or do you want to open up any discussions or anything that needs to be clarified on these two concepts? You can speak up. I know it's being recorded, but it's fine. Like, you can speak up, and if you have any questions, I'm happy to discuss that. All right. So as a quick quiz, whoever answers the first, okay, it's just there is no perk for this, but just to see if you have been attentive throughout the session. So let's see who is able to answer this. Yeah. Yeah, Radhakrishnan, you're on unmute. Do you have any questions for me?
Yeah, I'm just looking for additional websites that talk about patents and anti-patents in the during the course of internal development platforms.
Okay, so let me see if I can answer it in the next section, right? I'll look for some answers and I can answer that. But as I said earlier, there are 4 or 5 attributes that define an internal developer platform. Let me see if that slide is up there. Yeah, so actually this slide, I actually skimmed through it, but you see here, there are 4 or 5 attributes that are very important when it comes to internal developer platforms. So first one is a self-service portal, golden path. It has to enforce security and compliance. And then it has to have reusable catalogs. and helps resolve the configuration drifts, and it has to be collaborative. Now, these are very, I know it's at 1,000 feet a description of what this means, but in my opinion, there is no simple way to say the patterns and anti-patterns in this. While we walk through the the platform GoPaddle, I mean, I can actually talk about some of the architectural considerations that need to be made while building such platforms, because keeping all this the separation of concerns and reusability and everything into the perspective, Kubernetes itself does not give all those aspects. It does not cover those aspects. So we need a different level of abstraction on top of it, and a different level of separation on top of it. So when we talk about GoPaddle and how it is structured, you will probably, it will sort of answer how it is to be built. I hope that helps.
Yeah, thank you.
Yeah, I have one question. Like, what is the relation between DevOps and SRE?
Yeah, so DevOps is I would say it is it's a concept, right? It is not something that you can measure as a collaboration between Dev and Ops. Yes, it does have this mean time to detect, mean time to recover, and all this, but I still feel those are the SRE metrics, right? The maintenance metrics. So SRE is mostly on the maintenance, how service level objectives of how quickly you can identify, remediate issues, and have a high availability of your applications. DevOps is still, it's a philosophical concept of, how do you automate, how do you collaborate, and things like that.
Okay, thank you.
All right. So, any other questions? All right. So here is a quick question. So whoever answers first is just a quick. There is no perk, as I said. So who is the father of DevOps? No Googling, please. Okay. No. That's the wrong answer. Okay, so which means wow, who is that? Yeah, that's a good try, but that's also a wrong answer. Okay, it was Patrick DeBois. Okay, Patrick DeBois, he is the father of DevOps. Now let's go to the next question. Let's see if somebody can get this. Which was the first book that was written on DevOps? The first book that was written on DevOps? Okay, nobody knows. That's a funny answer. No, that's not the right one. I don't know if you've heard of this book called The Phoenix Project by Gene Kim again. Okay, that was the first book that was written on. Yeah. All right. So we will have a 10 minutes break. So we will come back exactly after 10 minutes. Me and Gayathri will be still in the room. So if you have any questions, if you want to chat, you can stay back. Otherwise, we'll come back in 10 minutes exactly. See you guys. Everyone is. Let's. I hope everyone is there. Yeah, I see everyone. Let's start with the second part of the workshop, which is primarily around, so moving forward, primarily around these two tools. backstage.
Vinothini,
Yeah.
sorry to interrupt. Like I didn't got that name, father of DevOps. Patrick, what is the full name?
Hey, boys.
Yeah, can you type it?
Oh, okay. Just a moment.
Yeah. Because when we are studying so much, at least we need to know the full name correctly. What I feel.
So yes, he has Patrick DeBois. You see here. And I don't know if you've heard of this popular conference called VelocityCon. So Patrick attended VelocityCon sometime, and Martin Fowler and a few others, they actually brought up this concept of reducing the friction between dev and ops, and that's when Patrick DeBois really internalized that. He saw the same problem is wide across in the industry, and he wanted to put a conference around this, and he coined this term DevOps Days. Right, so that's how DevOps came into picture, and it's quite interesting how DevOps has become a mainstream. How many years now? Like 2010 years, and a lot of things have changed, right? So from DevOps to it has blown up into a huge the platform engineering and everything. So but it all started with a small conference in the first place.
Okay, yeah. Thank you.
So next, let's look at. I know so far it has been interesting fact. Now we are going to go a bit into the backstage and Go Paddle as a precursor. Let me give you a heads up right away. So I was trying to bring up backstage for this session. Unfortunately, I had a lot of challenges with backstage. But I'm certain, there is a huge value addition in backstage. If I don't know how many of you have heard of backstage before. Can you type in yes or no in the chat room if you have heard of it? Please type yes. Okay. Have you guys come across? Okay. It's one of the very popular CNCF projects of late in the internal developer platform. And I've heard of many companies who are adopting it as well. But personally, I felt some things can be improved. So if anybody is contributing to open source, this is one feedback again. I was trying to bring up the backstage, and there's a lot of React knowledge that is required if you have to bring up actually the installation process, configuration process is a bit complex. But once you have something, once you know how to use it, the value that it brings to table is really good. So that aside, let's see what that other IDP is all about, right? So you see on the right side, it is you do a search, you get a set of plugins. That's the whole concept, right? So everything is plugin based, and what you achieve out of it, it gives a developer portal, and you can consider it as an app store for developers, right? So when I say app store, what do a developer need? Documentation, and they need some infrastructure to work on, and they should know who is owning what, and what are the interdependencies between multiple services, right? And it gives a developer-centric view of all of those, right? So that's all about it, right? So you can, create technical documents. They have a plugin for tech, it's called Tech Docs, and you can create a service catalog from your GitHub repository. You can link to your source control repository, and then say this is either a service, or it is a website, or it is a API provider, right? So you can create multiple such resources. You can say whether that is depending on other services. It will give you all the dependencies in a nice graph. And then you can also have many plugins. So you have Argo CD plugin, Go CD plugin. So you can just bring in all those Jenkins plugins. So you can add everything in the form of plugins. You can recreate your own plugins as well. So it's completely a composable platform. And based on the team's requirement, you can bring in whatever tools are required for the developers to work on. So the concept wise, it's pretty interesting. And as I said, like if somebody is able to bring this up, stand this up internally and start using it, it's definitely a good tool to, or a platform to look at. So again, going back to, I want to like get a feedback here. So anybody is using it from this team? Okay. Yeah. So we figured out like around 5 to 6% of the, we did a survey recently, and 5 to 6% of the teams are using, out of the 78 responses that we got, around 5 to 6 of them are using Backstage, and it is, again, it's helpful to them. Now, Backstage can be one side, and it can actually be the catalog provider, while GoPaddle is on the other side, which is a platform itself, the complete platform itself. So this is what GoPaddle is all about. So it's a platform which helps to build DevSecOps practice. It is for dev, support, and IT. Developers can quickly onboard applications. We have some tools and wizard-based approach to quickly onboard applications. IT can go and provision multi-cloud and even bring hybrid environments on board. And support teams can quickly troubleshoot through monitoring, logging, alerting that is pre-built into the platform. So we have around 30 plus tools pre-integrated. And we have 3 different subscription installers for this. One is a SaaS, where you can go subscribe and use. The other one is a community or a light edition, which is a single user, single node kind of installation for very lightweight startups and developers and consultants. And the last one is the enterprise edition, which is a full-blown scalable distributed system. Again, GoPaddle gets installed on Kubernetes itself, and it can scale based on the team size and the infrastructure. So these are the 3 different offerings. So today, whatever hands-on we are going to do, we will use the light edition for the demo purposes and for the hands-on. Now you're open to try other tools as well. This is not a pure promotion of GoPaddle itself, but like the previous question, right? So what are the patterns and anti-patterns? So when you look at GoPaddle, you get an idea of the design philosophies behind that. When you try out the platform, you know what kind of benefits you have and what challenges you might face. So I can talk more about GoPaddle because we have built this for years, and the challenges that we faced in the process has been numerous. Right? So building a platform like this requires a different design philosophies, a different pattern of building your catalogs and everything. So I'm going to just show you the structure in which the resources are being built. So that will give you an idea of how the platforms can be built, right? So I'm going to use this GoPaddle as a basis, and then you can derive some knowledge base out of that. Now, with GoPaddle, you get a good return on investment and efficiency because you have all these tools built in. You can have a shared ownership because if you are taking an enterprise edition or a SaaS version, you can bring in multiple team members and you can have a shared ownership. And there is no change in the developer workflows. Once the applications are onboarded, developers can continue with their same Git commits and Git push. They don't have to constantly learn or do some Kubernetes-based deployments anymore because those are sort of abstracted away by the platform. And you can eliminate a lot of...
looks like you unshared your screen, I guess. You haven't shared.
Oh, I'm so sorry. Oh, okay. I don't know where I stopped sharing. Hold on. Thanks for pointing it out. Yeah. I don't know if anyone got to see this slide. So did I share this before?
No, Vinodini.
Oh, backstage?
Yeah, backstage you shared, I think. Like this itself you
Okay.
haven't, I guess.
Okay, got it. Yeah. So this is the same principles that I talked about platform engineering. So you have a dev, support, and IT. Dev can use wizard-based approach to onboard apps. IT can provision multi-cloud, and they can have a centralized governance. And support teams can quickly identify and remediate issues through continuous monitoring, logging, and alerting. And we also provide some developer tools like container terminals and logs, so it's easy to resolve issues as well. So from the efficiency point of view, as I said, we have out-of-the-box tools, and you have a shared ownership, less friction because there is no change in developer workflows, and you can eliminate human errors because we provide low-code automation, so that eliminates human errors. So this overall, it increases the efficiency of your DevOps practice itself. Okay, so what are these low-code platforms? There are so many other low-code platforms itself. Low-code and AI is becoming an interesting topic of late. So can low-code and AI change the way we do things in the DevOps space? Yes, they can. AI, there is a GPT that is an interesting project that is upcoming. On the low-code side, so we are one of the platforms who offer low-code. So combined, you can see, next few years, there is going to be a drastic improvement in terms of how these platforms are being built and done. So low code is actually helps you to develop the application, deploy the applications 10 times faster. And going by what Chris from GitHub has been has been pioneering, right? So the code is not going to be the main event anymore, because you go ask ChatGPT, it's going to generate the code. He said this a few years ago, and this is becoming a reality today, right? Coding is not the main event anymore. Building the software is the main event. What is the core business? That has to be developed, right? So all these tools and automation over a period of time, that's going to be a boring task, and that is going to be automated to the fullest, while the developers and the teams would focus on their core business itself, right? So these low-code platforms, they give the visual models. They actually can do an automatic and a context-aware scaffolding. Scaffolding is the process of onboarding the applications. So that can be context-aware, and it acts like an IDE for DevOps, not just developers, right? So it's a development platform for the entire team, right? So it gives you an out-of-the-box experience. So that's where the low-code platforms come into picture. So to give you an example of a context-aware scaffolding, right? So you see on the left-hand side what AI can do. This is a one prompt that we ask ChatGPT to do. So the question is, go generate a multi-stage Docker file for a Spring Boot application. And you see, it gives the same generic, Docker multi-stage Docker file. Good for learning, trial basis. You can try all these. But when it comes to a production-ready multi-stage context-aware scaffolding, so to know exactly what your application is, you need some low-code automation, not just AI. Now, combining these two, you get a much more powerful automation. So on the right-hand side, you see this is generated by GoPaddle. This is a multi-stage Docker file generated by GoPaddle. It has identified all the environment variables, symbolic links, and it has identified codes and everything very specific to that application. So before we move on, any questions on this so far? I hope it's clear now, right? So what is a low-code platform and how it can help? All right, so let's switch gears here. We are going to go a little bit in depth into the patterns, anti-patterns. So this is a pattern that we follow in GoPaddle. So the way we have structured the resources attributes to these separation of concerns and reusability, right? So there are, like, as I mentioned earlier, the way and YAML is built, it combines everything into one single YAML structure. GitOps assumes that you will maintain all those YAMLs in different branches and different repositories. If it's not sufficient, if you have to deploy to multiple environments, then you maintain multiple branches. Now, when you have to extrapolate and scale, these two will not be sufficient. So we need to structure the resources and the process in such a way that it can scale, right? So the first one is on the config maps. That is, again, it's a Kubernetes resource. In GoPaddle, it is called a configuration. And you will have two different types of config maps or the secrets. One is the literal base, which says key value pair. You can say, a DB user is test, or if you want to make use of the underlying replica IP or a host IP, so we provide managed literals as well. But if you want to pick up specifically from a Kubernetes spec, you have a similar concept in Kubernetes called config map from or key from, right? So something similar is env from, right? So we have some similar concept here. So if you provide a kube spec, you can say which is that specific spec you want to reference in the Kubernetes YAML file, and you can give an environment variable for it. Now, the purpose of this is that you can use this within your application. Say if your application has to, respond back with the node name on which it is running. For instance, if you're bringing up a database, right, the master has to publish its node name, right? So in such case, you may be making use of this kube spec so that the rest of the replicas will know who is the master, right? So something like that, right? So that is one type of a kube spec. Now, this configuration is something that you have to pull out of your Docker image. You cannot package it along with the Docker image itself. This is one separate resource that you have to onboard separately so that your Docker image does not contain any environment-specific information and you can reuse it. That's one pattern or the anti-pattern that you have to pay attention. Right. The next one, it comes to the containers. Now, this is developers' responsibility. Now, this should not be mixed with the policies or the SLAs, right? Developers have to just focus on how they know what their network ports are, how to start and run their application, right? What are their configurations, at least for the development environment, what their configurations are, and what dependencies they have. So this is all a developer will know about that particular application that they are working on. And this application can be onboarded in three different ways. Either they have already built an image, or they have a Docker file-based project. They have already written a Docker file, or they have just a source code that is there when they are yet to Dockerize. So all they worry about is only this much, right? And this, to an extent, they also know if they have to run this application effectively, they know at least what is the bare minimum capacity they need to run this container. For instance, I need this much of memory and CPU if I have to run this container. So only this much is what a developer is interested in, and the rest of it is all at a much higher level where you want to compose things and you want to deploy. That's when the deployment objects come into picture. Right. So here we are actually talking about the policies. Right now we are associating policies on network inbound, outbound access, where this application has to be with specific node, or who or how it can be clubbed with other services like the service affinity and things like that. And you can also say how it can scale and how it can deploy. Now, part of it is defined by the policies, which are usually set by the IT administrators. Now, if you look, as again, going back to the same philosophy of YAML, everything is clubbed together as a single YAML. So that actually defeats the purpose of the separation of concerns there. Now, by splitting the resources, you can assign different roles and different permissions for individual users, right? So the IT can define the policies, and the rest of the developers can make use of it, or the DevOps engineers or the architects can make use of those policies. And finally, these deployment objects can be composed to build larger applications, which are called blueprints, right? These blueprints are a single entity that can be deployed. These are very much similar to Helm charts, right? We provide blueprints, which in turn can be downloaded as a Helm chart and reused, right? So this gives the overall structure, and this gives the way in which the separation of concern is addressed. So any questions here? This is the philosophy behind our resource categorization.
Hey, Helm charts to some extent provide that separation of concern. They have the values.yaml, which can be given to the developers, and the other things can be maintained by the platform team. So how does this, or what is the disadvantage of that, that you needed blueprints?
Yeah, so values file can be provided to Helm chart, but the Helm chart itself entirely, is a single unit, right? So there is no specific elements in the Helm chart which developers are contributing separately. So it's about deployment. Now, Helm chart is about deployment. Once the Helm chart is there, it's only about deployment, right? So how do we collaborate right from the beginning and contribute to a Helm chart?
Here as well, the developers would be using the policies that are already defined, right? How are they collaborating?
I'm sorry, I didn't get that question.
Right. You mentioned that there is no collaboration in a Helm chart. Only the values YAML is given to the developer. But in the case of blueprints also, the policies are defined by the platform team, and that is being used by the developers or architects in their blueprints. So how does it enable collaboration?
Yeah. So see, what I mean by collaboration is collaborating to the composition of the blueprint, right? Mm-hmm. So once the Helm chart is done, when it is given, the whole Helm chart is given to the user, and they can set different values.
Right.
Right. But how do we collaborate during the development of this this configuration itself? So each person owns a piece of this whole deployment. It is not owned by a single team or a single individual. That is the first notion that we have to break, because today YAML assumes that it is a single person who owns everything. But actually, there is an infrastructure team. So for instance, the storage itself, in a larger organization, the storage administration can be owned by a separate team itself.
Okay.
Right. Now, finally, everybody will collaborate, and the final outcome will be a Helm chart. And you can set different configurations through the values file. But even to create that, there are multiple teams who are contributing portions of that. Right. And similarly for containers, again, it can come from different developers, and the same container could be reused by different teams. So by separating these at a different levels of boundaries will help in reusability and separation of concern. Right?
Right. Yeah.
Okay. Yeah. So when you see the demo, you will get to understand why it has to be separated. Now, moving on to the multi-release. Now, GitOps, right? GitOps, as I said, when you extrapolate it, becomes a lot more complex. Now, that's where we have come up with this concept of releases and distributions. Now, releases. First, release is a terminology where each branch or a tag can be thought of as a release. Right? Every time you want to release something, you're actually going to, your code is in a particular branch or a tag. So we consider that as a release. Now, distribution is slightly different. So within a release, you can have one or more distributions, and each distribution tells you different way of building your application. For instance, you have to build your application for a specific multi-channel delivery. For instance, you have an on-premise installation. In our case, we have on-premise SaaS and everything. So the way we build our application, probably we will build it along with some license keys, right? So those building, the way we build itself is different under distribution. So a release can have more than one distribution. When you build a particular artifact within a distribution, you get builds. These are container images. Now, how is builds different from container image? What is missing in the container image today? So is the tag or the label. I think Docker has some labeling for these images as well. We are going with a similar notion. So we should know what is really inside the image, right? So you should know like which commit has gone in. Right, so that is a very key information to know what is there in a container image. So you should be able to associate that with a particular commit ID, right? So the build is a combination of a metadata of all this, where it was built, what is the vulnerability scan and reports around that, and what is the commit that is associated with that, which registry it is in. So it gives a complete metadata and it points to a Docker image. Now, this is the philosophy. Now, one container can have more than one release. And within a release, you can have more than one distribution. And within distributions, you can build it multiple times and create multiple Docker images, right? And what goes into a release is, as I said, as a source control account, a Git URL, and a branch. A distribution tells you which registry it is going to use for pushing the images. And for a multi-stage build, especially, you need to know what is the build time image, what is the runtime image, because build time image may have all your, Maven and other build tools, whereas runtime image may be a slim image. And you need to say how to build it. When you are building it, you're making use of the Kubernetes environment itself for building a Docker image. We in turn use Kaneko for our builds. So we have to say how much of capacity you can allocate for this build. Now this eliminates the need for setting aside a separate environment for like a Jenkins for building your applications. You actually make use of Kubernetes itself as a shared and elastic infrastructure for building your application. And if you're using a Docker file-based container, then you can also say where the Docker file resides, so that we'll be able to pick that Docker file and make use of the Docker file for building a multi-stage environment. So any questions here? Now this is one way of building. Now this is slightly different from the GitOps. If you're doing GitOps, this multi-release, every release, it can be managed as a separate branch. But what happens when you have to manage multiple environments? So how many branches should we have to create? And how do we keep all of those branches in sync? So it's become impractical with respect to GitOps when you have to manage multiple releases, multiple distributions. So this is again another pattern or an anti-pattern, which you have to keep in mind when you're building a platform. Okay, so once you have built it, and now this is something specific to GoPaddle. So I probably when you do the hands-on, you can make use of this, right? So you have launch types. When you launch the application, is very similar to the Kubernetes concepts itself. You can use a node port to deploy. So it will take the node IP. The application launched will have the node IP and an alternate port. So while launching, you can also provide the port. Alternate port for your application. Suppose if your application is running on 8080, you can give an alternate port saying 30,001 or something. So so that Kubernetes will know when the traffic comes to 30,001, it will redirect it to your application's port 8080. We also have additional subtype called ingress without load balancer. So when you don't have a load balancer, but we still, if you want to have a routing using Nginx, you can use this option. But for this to work, wherever you have to use ingress, you have to make sure that your container has some route paths enabled, right? So that Nginx will know to which container it has to route to. Ingress with load balancer is when you have a cloud-based deployment, or if you're using an on-premise cluster. Say, for instance, Metal LB is one load balancer that can be used for your on-premise software load balance as a software load balancer. In any case, where if your cluster has a load balancer, you can add an ingress and then load balancer and use this ingress with load balancer option. So for this, your endpoint would be mapped to 443 and 80. Okay, so this is just an additional information. This is probably it is a similar concept in except for this ingress without load balancer. These are very similar in Kubernetes as well. Okay, so now you have deployed the application. Now you have to have these activities, events, rules, and notification. Why is this important? Because you need to know what is changing within the system, and you should instantly get a message to know how to react to that and then fix that issue. For some reason, this icons are not showing. So any activity is something that user is performing something within the system versus the events which are system generated. So activity could be user provision something, right? System could be something failed in the system, right? So you need to set some rules to say if an activity or an event comes, then you have to act on that activity. And the rule says, so if an event or an activity comes, the rule says go, publish it in a specific notification channel. So, if this event comes, go to this channel. If this event comes, go to another channel. So that is a rule that says how to act upon those events and activities. We have a wide variety of channels that we support, like AWS SNS, Slack, PagerDuty, and Jenkins. So what is the alternative for this? Is we actually built this on top of Prometheus event exporters and node exporters. So these are pretty much available in the Bitnami Helm charts. You can set up the whole thing with just the Helm chart. Now, where the challenge would be is on persisting this information over a period of time, right? And also integrating with different other notification channels. If you want out-of-the-box solution, then GoPaddle provides. But there are tools that you can directly take from the open source. You can build it as well. Okay. Now, what are the different activities? So these are user-performed activities. Now, GoPaddle does the monitoring of the activities as well. It's not just the events alone. So why is this important? Because usually, sometimes these events may be triggered because of one of the activities that the user performed. So it's important to know what caused the failure, right? And especially when you have a distributed team, who caused that who triggered that activity is also important. So that brings in a level of ownership within the team. So somebody goes and adds a node pool, or somebody deletes a node pool, that could actually trigger service unavailability, and there must be some way to track all these things together, right? So some of the activities are across builds, applications, and clusters. Build says whether it was created or scanned for vulnerability. Application is all these like rolling updates, rollbacks, any image secret updates, volume updates. All those things are user performed activities. Similarly, for cluster, you can actually add node pools, delete node pools, or update a cluster for, say, you add a new label to a node. So even that is a node pool update or a cluster update, right? So all these activities are tracked. Now, events, again, this is a classification. This is again based on Kubernetes. So the application can have a certain set of events. Cluster can have a certain set of events. This can be across the kube system, user applications, irrespective of whichever namespace they are in. You have different categories of events that can come across different resources, right? All these events have to be monitored. Okay, I'm going to give a pause here. So any questions? It's been like more than 30 minutes. I've been talking on the resources and the events. Any questions?
You talked about secrets as a configuration. I'm assuming that's the Kubernetes native secrets. Do you also support the secret stores offered by the cloud providers?
Vault, you mean? Vault and others?
Yes.
No, that's something in the roadmap. We have another tool called Configurator, which is an open source tool. We are actually, working on getting that into the GoPaddle platform itself. So what it does is it manages the config maps and secrets and keeps them in sync with the deployments, right? So as a part of it, we are integrating with Vault, but that's something work in progress. We don't have Vault or other secret integration at the moment.
Okay. Sure, thanks. One more thing is like, I think the secret stores also offer a kind of a storage interface, where you can mount them as files. Probably that's also one way of bringing the secrets.
Yes, so we are, in fact, we have done some POCs around Vault integration. But what they don't have is keeping a version controlling those config maps. So again, the question here for the rest of the folks, like, have you ever faced versioning config maps or a change in a config map causing a problem in your application deployment? Okay, so if you have not played around with Kubernetes, I think it's an interesting topic to learn, because changing a config map, and unfortunately in Kubernetes, config maps are not version controlled, right? Every other resource is version controlled, and config maps are not version controlled. You change a config, it can break an application, and there is no way of going back. Even though there is a rolling update, rollback concept in Kubernetes, it's not possible to roll back if the configuration is messed up. So that's where we are coming up with a solution called Configurator. So as a part of the project, we are also, we did a POC on Vault integration, so we are yet to bring it to production.
Thank you.
Okay, another 5 minutes, we will finish this, and then we can go on a break. The CI/CD systems, these are built primarily on the alerts and notifications only. So the first step is in the container, you can enable a continuous integration. And as soon as that is done, GoPaddle will go, it will register a webhook based on whichever, you are enabling the continuous integration for a container within a specific release, right? Because everything is release based. So for a release, you can enable continuous integration, and it will go automatically register a webhook in your GitHub account. And later on, you have to create a Jenkins job for the CD. So the CI is native. CD, you have to create a Jenkins job. Then you can create an alert rule to say, as soon as the container is built. So as I told you, it's the one activity that the user is performing, right? So the activity says the create build is completed, right? Once this build is completed, you're saying go do a rolling update, right? So the rolling update is basically, calling the GoPaddle API to do the rolling update on a particular service. Now, this may look a little complex, but we have a quick start wizard, which is just 3 steps. You will have the entire CI/CD pipeline set up. So Gayathri is going to show that demo in a while. So all you have to understand here is that you are actually taking a source control based or a Docker file based container and enabling a CI for it. And when you do that and you build up a pipeline, anything that you commit in your source code will automatically, you can run vulnerability scan and everything. Built Docker image is pushed to a particular registry, and then the pipeline automation will also do a CD on a rolling update onto a deployed application. Other terminologies to note. So we have 2. This is again another pattern which you may want to watch out, because if you're building a catalog, you want to make sure that the names are unique. But at the same time, when you are deploying to Kubernetes, you may be deploying to different environments, and you may want to keep a different name for your Kubernetes deployments. So this is one challenge that we faced, and we had to introduce two names. One is for Kubernetes naming convention, another is for a catalog naming convention. The second one is about versioning the artifacts. Now that you are maintaining the artifacts differently, because the Git branches are not enough, you need to have a mechanism to version control those config maps. I mean, all those artifacts, that YAML files, right? So we have a native versioning mechanism. You can go commit the configuration, and there should be a way of maintaining the resource dependencies, because now that you are splitting and having disparate configurations, you should have some way of maintaining the dependencies between these resources. So these are other things that you have to keep in mind. Right, so I'm going to stop here. This is all we need to know as a groundwork before we get into the demo. As Again said, you can make use of this coupon code. You can you get a 3-month subscription, and you get multi-cloud capabilities as well. You'll see what is feasible. So it's a very powerful tool, and you get this tool for just 3-month subscription. You can play around with that, and you can build a small platform in-house just within few minutes. Okay, so we will stop here and we will take a break. Before we go on a break, anything that you want to touch base in the next few minutes, I can spend some time to think over it and bring it up in the next session. So let me know.
I have a question, probably not a suggestion for the next speaker. So one of the features or something that is required for a production application is changing the log levels so that some debugging can be done. Now, is there a way to do it from the developer portal so that you don't need to go and change the config map manually and then push it? Is that a valid pattern that you see in enterprises?
It is very application specific,
right?
And you can decide whether you want to build it. I mean, if you build it internally into your image, there is no way of changing the log level when you want to debug it. So it's better to bring that out as a config map.
Yeah, I understand. It has to be in a config map, but how do you or how do we do it? Or how do we flip the switch for that? Without checking out the config map, changing it, committing it back, doing all these things.
Yeah. So all these catalogs that I said, they are version controlled but the live application, if you want to, it's a choice that you want to make. It's the entire config map. If you want a version control, you can try out a configurator, right? If you don't want to version control, so it's only either zero. It's either this or that. So either you version control the entire config map, or you don't version control it. If you version control, then you have to change the entire contents of it. So there is no specific field that you can choose whether to ignore or not, right? So I don't see any way of that is when you use configurator. There is no other solution out there that version controls config maps at the moment. There are tools that does rolling updates based on a config change, but you still do not have a versioning for config maps, right? But if you choose configurator, then the entire config map gets version controlled. There is no specific portion of config map that can be versioned.
Understood. Thank you. And one more thing is like the versioning of the config maps, right? That is followed in case of a GitOps flow like Argo CD. So how is this different from the Argo CD or other GitOps tools?
Yes. So rolling update is possible, but rollback is not possible. Even if they version control it, it is not it is not tied to a deployment version.
Okay.
Right. So deployment version 1 may actually use version 1 of config map, right?
Right.
Deployment version 2. So there has to be a link between these two. Ultimately, when you want to roll back your config map, your deployment also has to be rolled back. Right. So that connectivity between these two is a missing piece.
Okay. Understood. Thank you.
Okay, so let's I promise next 2 sessions are going to be interesting. So only the long theory session is over. So only good things can happen from now. So let's take a break and come back in 10 minutes. And it's going to be interesting from the next session onwards, because we're going to see some live things and we're going to try some live sessions. Okay. All right. Let's come back in 10 minutes. So now, okay, we have come to the third part of the session. So we are going to do some demo, and I'll also present one use case of how GoPaddle can be used. So we'll start with the backstage demo, and we will then look at GoPaddle, right? So as I mentioned earlier, I had some difficulty bringing up the backstage. I just followed their documentation, and I think I got lost somewhere, and I couldn't bring up few aspects of the plugins. Some are core plugins, and I could not get those things working. But I can show from the concept wise how it can be used and what it is all about. I was hoping, in fact, to show the Kubernetes integration. So this is the backstage platform. This is the home. Okay, so you see different types of components being onboarded. The components could be services, some could be APIs, websites. It can be any component. You can define your own component, whichever is known to, or the terminologies that your teams are aware of. You can bring in environments. So all belong to the components. And you see here, I have 2 websites. These are just simple sample websites that are onboarded. Social is one website, and you can assign roles. You can also assign specific systems. Now the systems is just a conceptual thing. These actually don't necessarily mean your Kubernetes systems. And you can also tag them to a particular life cycle, whether they are in production, staging, experimental, whatever stages you want to set it. So if you actually go into one of these components, you will see on the right side the relation between the components users. So group, this component this group guests has actually created this component, and this non-social component is dependent on another component called example website. So let me increase, sorry. So you can see it clearly here, right? So group guest is the owner of this component, and this particular component has a dependency on another website. And you can add reference links. And you can also have subcomponents within this, but I have not added one. So it gives an overall view. Now this is this is a core, the view doc, technical docs. Tech docs is a core plugin. So you can add your technical documentation related to this particular non-social application itself. I could not bring this up. It worked in between for some time, and then all of a sudden it stopped working. So I have no way of fixing this. However, like you can have your readme.md file or index.md file, and you can actually visualize the documentation here. You can also define APIs. For instance, there are 2 APIs. Let's take a look at the gRPC API. This is provided by the default installation itself. So here you can see that, again, groups and the systems that own this particular API resource, and it is being used by another example website, right? And technical documentation, again, would look like a open API documentation, like a Swagger kind of a documentation. Unfortunately, it doesn't work now. Okay. So this is the raw gRPC API, but if you have an open API, it will actually show in the form of a Swagger documentation. Right? You can create your own resources by registering your existing component. Suppose I have an application, for instance, let's take another sample, chatting study. Right? So this is one application that I need to add to my catalog. Then all I have to do is to take the URL, git clone URL, and register this component here. So it will analyze and it will see whether this particular catalog info.yaml file is present in the repository. If not, it is going to add and commit. It will send a pull request. You can define who the owners are for this particular component. You can create your own groups and entities, owners, and you can assign an owner. And then when you create a PR, it's going to send a PR to this particular repo. Okay, and once you merge this pull request, it will add this particular service to the catalog. So once I merge it, I import it, and that's it, right? So this pull request is already closed. So if I go to the home page, it will automatically show that the system chatting study has been added, right? Now you can go and edit this YAML file. So this is a YAML file again. So you can edit this YAML file and then create more definitions. So I can show you what I have for non-social. So again, you're dealing with their own specification, resource types, and YAML files. But it is quite powerful if I had been successful in bringing this up. This is quite a useful open source IDP because you're creating catalogs, you know the ownership of it, interdependencies of it. So if suppose I have these interdependencies defined here, if somebody changes the dependent resources, then it automatically gets refreshed. So all those transients dependencies are all kind of handled seamlessly, right? So you can define it like, it is a component type. You can also have templates, APIs. You can give a definition to it. You can label it. You can annotate it. So the annotation can be used to integrate with other plugins. Say, for instance, if you want this particular service to be the CI/CD to be managed through Jenkins or a Go CD or Argo CD, you can add annotations to the service catalog file. And then you can also create links which can point to external links. So if additional documentation is needed, somebody can go, reference this page, or it can point to dashboard. So it's a sort of a centralized communication mechanism, right? And you can also create dependencies and service composition like this. So it can say it depends on other components. So this is all about the backstage. Another configuration that you may want to note is that you may create docs. For instance, I have created, and I know this is the documentation that will show up inside the technical docs. All right. So for instance, if I go to Mern Social, ideally, when I see the docs, it should have actually shown here. However, something is breaking. So what we have to do is to create a docs folder, and under that we can specify a index.md file which has all the documentation. And this mkdocs is another technology which is also the mkdocs is quite a popular documentation for a static site generator. So here this defines the location of the home page, right? And the plugin, this is again the plugin in Backstage that will generate the mkdocs, right? And once you define this, automatically this will get recognized in the Backstage portal. So in the config info.yaml, we'll have to just say that the technical document reference comes from this docs folder, right? So this is the docs folder. So it will refer the mkdocs YAML file here, and it will pick the index.md file as the home page. So this is one powerful use case. You can also define CI/CD. So here also I was not able to set up Jenkins. And this is also available as a plugin to the Backstage. There are so many other plugins. There are even cluster provisioning plugins that are available. It's just that the overhead of configuring all of this and making it work, right? So this is one. And any questions on Backstage? So do you use any tools internally today to maintain such catalogs other than Backstage? Have you heard of anything else? Or have you ever felt the need for such a platform? Come on, guys, let's make it more interactive. No such tool. Okay. Yeah, so that's not exactly like Backstage, but okay, Morpheus. Okay. Morpheus is more like a multi-cloud provisioning platform, right? Yeah. Okay. Awesome. Okay, now let's go to the fundamentals now. So how are you generating the Docker files today? What is your typical turnaround for generating a Docker file? Say if you are given a Java application. Okay, say let's take a Spring Boot, which is the usual thing. So how much time do you take in creating an optimal Docker file for it, a multi-stage Docker file for it? Oh, you have an internal tool. Okay. How about the rest of the folks? Like, do you use any tools, or do you have to handwrite everything? Manual. Okay. Yeah. So that's where the first phase of your transformation comes. Yes, manual. Most often it is a manual phase, and we go with the approach of iteratively improving the Docker file till a point where it is optimal and the final image is smaller and secure, right? So typically, it takes about in our own experience, we have seen around 3 to 4 days to have a multi-stage file, multi-arc file that is optimal and it is smaller, right?
Quick question, like
Yeah.
with the Docker file, there might be a need for integrating, let's say, something for the observability, let's say Datadog agent or those things. Do you also handle such requirements?
As a part of Docker file generation?
Yeah.
So that's more application specific. Again, it's a more application integration, right?
Right.
Yeah. So it's purely, I'm talking purely about a multi-stage Docker file, which is very context sensitive again, right? So now I'm going to introduce a new tool. So we have not spoken about it in any of the conferences or in the sessions in the past. So this is something very, very new. And This is called a GPCTL Gen tool. I know like there are new tools coming up like scaffolding in it, but this is very context aware tool. Okay, I'm going to show what this is capable of doing. All right. So let's take the Spring Boot application. So now this is a Java application, and we have to generate a multi-stage Docker file for this. So as a developer, we just need 4 things which are essential to build and run this application. I don't have to know Docker. I don't have to know Kubernetes. I don't need to know any of those things. All I know is how I can build this application. This build script, if you see, it says I am going to run this on Ubuntu. So it says I have to do an apt update, install JDK, curl, and Maven, and I have to do a Maven install. In fact, curl is not needed. I just need JDK and Maven, right? So this is the first step, right? If you see, this is a self-sufficient build script. When I say self-sufficient, it installs all the dependencies, even if it requires any environment variables or any other dependencies. This has to be self-contained. You assume that you're just going to run this inside another container, which is a FreshView container, Ubuntu container. There is nothing else. Then you have to make sure that whatever is required to build this application is provided as a part of the build script. Now, this is the build phase of your multi-stage Docker file. So build phase assumes that you're going to run within a container, you're going to build the application. So here you're just providing all the steps to build. As a developer, you have to just know how to start the application, right? So this is going to be your runtime, what do you call, entry point, right? So you say, I want to run Java jar, and you give the target location and the jar files. You have to say how to stop the application. This is to make sure that your environment is cleaned up once you have finished your generation, Docker file generation. So it says in this case, it is actually going to look for a Java process and it's going to kill it. And then you are going to say how to check the health of the service. So even after you start, you need to say how to validate whether your service is up and running, right? So this is basically a curl command to hit an endpoint, which returns a 200 success code. If you want to add, you can also add a test script. In our case, I'm just going to wait for 10 seconds. So that is the time period for which this discovery is going to happen. Now, if you have a unit test or a regression test, you can add the script to run the regression. So the more coverage it has, the better your final Docker file would be, right? It will have a more holistic coverage of all your dependencies and everything. Now, having written these 4 or 5 files, this is all we need to generate a Docker file, right? Now, this, if I have all this, why can't I just go and write my own Docker file? The question could be, why do I have to use a tool like this? Now, you don't have to package everything. You really don't know what is an absolute necessity for you to build a very lightweight Docker image. Am I packaging more or am I packaging less? Will it work in the final deployment? So all those kind of optimization comes into picture, right? So what we do is we have this tool which is called a GPCTL gem, right? You don't have to even give this. So if you have the test script named as test script.sh, then it will automatically pick up. The start period tells you how long it takes for your application to move to running state. So when you run your start script, sometimes, if it is a large application, it may take 10 seconds or 60 seconds. So we just need to know how long it takes. The runtime image says what is the final, image that you have to use for your phase 2. If you want to use a non-root user, you can provide the non-root user. If you want to override the envs, you can give it as true. So the override env says that during the discovery process, if you come across any envs that is not that is overlapping with your system, you can just use what is discovered from the application, right? So just this command, and this will automatically generate the Docker file. As you can see, there is no Docker file in this project. So it's going to create a Docker file. So what it's going to do is to create a user. It waits for a few seconds before it starts. It validates the health check, and then it will start the discovery. So this hardly would take 5 to 10 minutes, depending upon the size of the project. So I think this should be really quick. Okay, so it has done some discovery on the environment variable. Since we have given the override option, it is going to override what is discovered, and it has identified that the libraries and the symbolic links. And then it is finally adding your entry point, and Docker file is generated. So let's take a look at the Docker file now. Okay, so this is a multi-stage Docker file generated by this tool. So this has taken the Ubuntu as the base image, and this is the stage 2. So by default, we are setting this to Ubuntu. This is a tool that we are going to publish very soon in the Docker desktop as well. But there is a possibility of customizing this in the future versions. But right now it is taking as Ubuntu 22.04. Right, and this is the image that we provided while initiating the tool. Then it has detected everything else. Right, so it has the full-blown multi-stage Docker file generated with non-root user, and it's going to be lightweight because it only imports whatever is the absolute necessity, and it has a complete working version of it. So I'll stop here for any questions on this.
During generation, does it run the the application and observe its behavior? Is that what it is doing?
Yes.
Okay.
So in fact, you can build this and build an image and run it as well. So for the benefit of time, I'm not doing that process as of now. But this actually supports .NET Core, Golang, Node.js, Python, right? So different types of programming languages as well.
What are the different aspects that it observes and takes into consideration?
Yeah, so you can see it observes the ENVs, it identifies the dependencies, and then it also has all the symbolic links. If you have a volume, this version doesn't have the volume mounts are also covered. Health checks, anyway, this is something that you provided as a part of your health check. This entry point also comes from your start script. But the remaining, all of these dependencies are discovered.
Okay, thank you.
Right. All right. So once you have this, once you commit, right? Once you commit your Docker file, now the actual platform comes into play.
Yeah, Vinitha, one question here. Still, I am not clear what exactly this GPTL. Is it a library from any GitHub or?
Oh, this is our tool. This is GPCTL.
Okay, your tool. Okay.
Yeah.
Okay.
Command line utility. So this is something that it's a GoPaddle command line utility.
Okay. Thank you.
Yeah. So it hardly took 5 minutes for us to generate a multi-stage Docker file. Right. So your transformation starts from here. Now I'm going to hand over the presentation mode to Gayathri to take it over from here. So she will show you from once you have a Docker file, once it's committed to the source control. So that's one way of starting. You can use other systems to go ahead and then build a CI/CD pipeline from there. You don't have to use the GoPaddle platform as such. But suppose if you're using the platform, she will show the workflow on how this whole the entire automation can be handled. Over to you, Gayathri.
Yeah, thank you, Vinothini. Okay. Yeah, actually, like Vinodni explained, suppose you have like your own like you have a source code and you want to generate Docker file and you want to like deploy it on application, means you can simply use such kind of tools. Suppose if you have an application and you don't want to like write the Docker file or any of these kind of thing, then simply we can through GoPaddle we can able to deploy your application from scratch without writing any Docker file or YAML or any other kind of scripts you don't have to write. So for our like a demo, I just forked a simple Spring Boot Hello World application from the public GitHub repository. And here you can see that they have provided one README file for this. So like for based on this README file, I just I can able to build and run this application on my desktop. For example, like for this application, we need for building this application, we just need to execute this ambient clean install command. Let me. So this this ambient clean install will build your source code, and it will generate the binary inside the target folder. Then for running the application, like they have mentioned how to run this application also. I'm just again following the same, and I'm running it on my local machine first. Now you can see that the application is started. So I'm just accessing. Okay. Okay, yeah, here itself they have mentioned how to access this application. Like they have used hello. Okay, yeah, this is this is how so now I can able to build and run this application on my my desktop. Now what I'm going to do is I'm going to deploy this application on Kubernetes. So for that, what we need is we just need two things. Like one is like as a developer, we just need to specify how to build this application, like this project, and how to run this application. These two things we need to mention, like while creating the container artifacts. Let me. Okay, like here is the GoPaddle dashboard. And here, like for creating the new resources, we just need to go to Design Studios, and under containers, first of all, like we need to create from the container resource. Like for our application, I'm just giving the name as Spring Hello, and the display name also same. And like here you can see that three kind of artifacts we are supporting. One is suppose we already have a Docker image, then we can simply go with Docker image based approach. Suppose if we have the source code project only, we don't have any Docker file or any kind of thing, means we can just go with the source code option. And here we need to specify how to start this application. For that, I'm just copying the start script from here. I'm just using the same. And here, and then like remaining steps, we need to specify like it is the wizards are more similar to Kubernetes container spec. We need to specify the security context for container level. And like we can able to set the capabilities, and similarly we need to set the network port information for this application. Like I'm setting the network port, and if we need, then we can also set the route paths also here. I'm just going with the port itself. And suppose if you want to add the health check, all such kind of information, then we can add all those information while creating the container itself. Then if we have any like a mount path or anything that are there in the like a project means we can mount all of them. Suppose that project contains any config maps means we can like add here itself. We need to create the config maps for that, and we can mount the config maps here. For this application, like there is no config, so simply I'm just going next. And the similarly, we can expose the envs also. Then dependency. Suppose our application, say example, the hello world, or maybe our applications depends on any database like MongoDB or MySQL means we need to before coming to that actual service, the dependent service need to move to running status. So such kind of dependencies are available means maybe we can add it here, and it will wait to move to that dependent service to running status before starting our actual services. So there is no dependent services, just going with the default options. Once the container is created, these are like whatever I added. It's moreover the Kubernetes specification only. But we need to build this Docker file, and we need to generate the Docker image for proceeding further. So for building the Docker file, what we need to do is we just need to specify the project URL. So I'm just this project is in GitHub repository. So I'm just choosing the provider as GitHub, and I'm just choosing the source control account. Actually, this source control account we need to create separately. Maybe after the container creation process, let me explain the source control creation part. So once we chosen the account, source control account, we need to give the GitHub URL. So I'm just copying the URL. Yeah. Once the URL is copied, it automatically lists all the available repository information, like all the branches here. So we can choose our branches accordingly. Then here another thing, whatever architecture we need to build, we can choose the architecture here. Now I'm just going with the default. This is the AMD 64 architecture, and this UID and GID. Suppose if you want to add any UID and GID specific to the Docker file level, that image level means you can add here. Then the build image and the runtime image. This, like Vinothini explains about the multi-stage Docker files, right? So in the stage 1, we usually build the whole project and generate the binary out of it. So for that, we need to specify one image, and the final second stage is a runtime image. Once the build is over, we are just copying the binary, or we whatever information, whatever files we need, we are again copying it to the next stage. So here itself we are getting the separate images from the user itself. So for that, I'm just adding the OpenJDK image, so that we don't need to install any Java kind of things, no. So for that, I'm using the OpenJDK image, and runtime also I'm just going with the OpenJDK image. And here, suppose if it is in from private repository, then we can specify the repository information here, and the distribution registry. This distribution registry means once the build process is completed means it will generate the Docker image. Then we need to specify which repository it needs to push. So that information we need to specify. Actually, we can create like a GCR, ECR, or any OVH kind of registry, like whatever registry we need to we want, like we can specify accordingly. I'm simply going with the Docker Hub repository. Then here we need to specify mainly two information. one, like this build directory, by default it will take the root directory of your project. Suppose if you have multiple project you are maintaining in one repo, means you can specify the exact path of that projects, like services separately. Then this output directory, already I mentioned about the stage one. It will build your source code and it will generate the binary for that. So if you haven't specified any output directory, means it will copy the entire files to the final runtime image. So for avoiding that, we can specify the target output directory. For our case, like all the binaries, everything generated under the target folder. So I'm just specifying the output directory as target. And here we need to specify the build script. Build script in the sense like how to build this application. So for building this application, we again taking from the README file itself. But here, like we need to add one more thing. Like we used OpenJDK image, so we don't need to install Java kind of thing. But we need to install Maven for building this source code. So I'm just installing Maven plugin also. Once the scripts part is added, then we have to specify the build capacity, like which means how much CPU and memory capacity required for building this particular project. So depends on the project, we can specify the request limits and like memory limits. So like based on that, for quick build, I just gave the little high CPU and memory capacity. I'm just giving the finish. Yeah. Now it just created the container for our project. Now we need to build the project. So for that, I'm just clicking the build. Yeah. Here now you can see that our source code project is here in building stage. So here you can see that the source code GitHub repository information, like which commit it is building, and like the commit message and branch information and all. Then in the below, like it will show you the build environment also. Like here I used the local cluster. So already like I have created I have created a microKTs cluster and register on top of the this GoPaddle platform. So it is building on that microKTs cluster, and the let me refresh. And it will show you the like which node your build process is scheduled and all. It will show here. And here the activities, like it will show you the like build activities, like what level it is in and all. It will show here. And under the container logs, it will show while building the source code, it will show like what are all the things are happening and all. You can see here. Suppose if any failures happens also, like based on this log, you can fix your failures. So it will take around 1 or 2 minutes. So in the meantime, let me quickly show you the environments part. I already mentioned, like I have created one microKTs cluster and registered it as an external cluster on GoPaddle platform. So once you registered your, suppose for example, you have the pre-existing cluster, means you can register it over here. Once you registered it here, it will here itself, you can maintain your clusters. It automatically after registering this cluster, it automatically discover the application, like whatever application you are deployed earlier in the pre-existing cluster. It all will discover here, and you can see all the application here. Like all these applications are already running on top of this particular microKTs cluster. And then here you can see like various node information. Yeah, like the node like architecture kind of information and labels like all here, and the Docker images like whatever images are inside this kind of cluster, also like nodes also you can here see here. And finally you can see the all the like node related logs also. Then again here cluster itself like you can even create your like internal clusters also, like AWS, Google or Azure kind of cluster. And if based on the necessary. So let me check the build process. Yeah, now the build is got created. Now once the build got created means we need to create the deployment spec for the our project. So again I'm going back to Design Studio. Under deployment objects, I'm just clicking on the deployment. Here we need to create a deployment for our application like project. Let me. Here you can specify the various policies, like here deployment policy in the sense like the replica count, like replica information, like revision history, update type and all. Then scaling policy, like HP, like horizontal autoscaler kind of information you can configure here. Then network policy, like if you want to add any network policy for your project, then you can specify all such kind of things here. Yeah, here itself we can add the like whatever we will add in the deployment spec level, like annotation, affinity, all kind of things like in the this wizard, these wizards we can add. Now the like deployment for this Spring application is created. Now what we need to do is we just need to add the container, like previously we created a Spring Hello container, right? So that we need to add inside this deployment spec. For that we need to specify the like allocation policy. Like earlier I have specified on allocation policy, actually that is used for building our source code project. This here whatever we are specifying, it is at the deployment level configurations. So I'm just going with the default option and I'm just exposing the external port. Yeah, now the container is added inside this deployment spec. Those information you can see here. Once the deployment is created, and again you need to create the blueprint. It's something like it's a complete unit for all your deployments. For our case, we are simply have only this Spring Hello deployment alone. That suppose if we have multiple 4 or 5 services, we can create all of them separately and we can club everything in the blueprint section. So once the blueprint is created, then final stage is the application deployment. For that, just click on the launch option here, and here just we need to specify the a few information like the application name. Then we need to select the we have created the blueprint, no? So that those blueprint information we have to select here, and like this will validate the container image validation. Like we have created the container and we did the build and we generated the Docker image out of it, no? So it will validate all such things. Then next thing. Here we need to specify like what kind of launch type we have to select, like is it load balancer type or node port type or ingress with LB or without LB, all such kind of information we have to select. For this application I'm just going with the node port type application. So we need to specify the alternative for port for this application. then env, like if this again, like suppose we have added the env in the container level, but at the launch level I want to change anything, means we can edit it here over here. So similarly config also we can edit. So here is the node selector information. Suppose if you have like if you want to launch this particular application on a specific host name or any specific architecture kind of things. So all such kind of configurations we can do here. Then here node level affinities we can add at the launch wizard itself. Now the application deployment is started. Here you can see here is the like a simple dashboard for your Kubernetes running application. Like let me here you can see various information. Like in the first level, you can see the CPU usage and memory usage metrics. And second level, the KATS specification, like the container information, like image pool policy, container level security group, security context, allocation capacity information, environment variable, config maps, such kind of. Then similarly, here it will show you the deployment level specification, like a pod level security context, then a network policy information, various policies like scaling deployment policy, affinity rules, then a node selector, annotation, all the labels, all like whatever informations are available in the deployment level, we can visualize here. Then here it will show you the complete revision, like what is the image version currently we are using, and here this revision history will show you, like if we are editing, going to do any rolling update, like suppose we are going to update any scaling policy or any, again you're changing the image or such kind of like rolling update information, like rolling update history you can visualize here. Then let me, still it isn't create, like it has some issues, looks like. Let me check. This is the actually container level information. You can see that it is in like it has some issues. It is in crash log backup state. Let me check the container logs. Okay. Actually, like the path, like in the start script, I have mentioned one path, like target / hello world application, right? Like let me. Yeah, here I have specified something like the path, like a target / hello world application, that jar file information. No, but in the like build phase, I have mentioned like / target, which means like it will simply copy like what are all the files or binaries which is available in the target file alone, will copy to the our runtime image. So it won't like the target, like the folder reference target may not have like may not have, that is the problem. So for that I'm just removing that target reference, and I'm just committing this application. So like one important, like one key feature is like here itself, like once the application is onboarded, here itself you can like update your, edit your like Kubernetes YAML files. You don't need to do kubectl and kubectl edit command, and like you don't need to go and edit your YAML files. Like here this UI itself, you can able to edit your all your Kubernetes YAML files. Let me. Yeah, the script got updated. Now it moved to running status. Let me access this application. again, it is not accessible. So again, like I used micro-K8. So yeah, ports also I already opened, like 17 is already open. So mostly it could be because of the network policy. Like already, like I just simply go with the default network policy, like which means the port number 2020 only exposed. So we need to expose the like our TCP 8080 port number. So 8080 only the application is on running. So I quickly change this. It will take few seconds. Yeah. Yeah, it got updated. Now let me try accessing. Yeah, it is already. Yeah, now the application is deployed and I can able to access the application. So like here I haven't like here you can see that I haven't like created any of the Docker file or YAML or any kind of thing. If I have like suppose I'm a developer, I have a source code like how to build and how to run this application. That information I know means like simply I can like deploy it on the Kubernetes environment.
Can we
Now,
also see the container terminal on the logs?
yeah, sure. Yeah, here like here it like I earlier I showed like about like about the container logs, right? So similarly, we can like here this dashboard itself we can access the container terminal also. So here like so like this is like these kind of things maybe you can like for your debugging kind of things it will be useful for that angle. Now let me quickly show you the like CI pipeline, CI CD flow for this particular application, this Spring the Spring Hello application. Like before going into that CI/CD setup, let me quickly show you the like various alert rules we can set it on the app, this running application or build or in the cluster level information. Say example, like if we have the cluster, like we have production ready cluster, like we need to monitor the cluster like frequently, like if any disk pressure is happening or any node eviction or pod evictions are happening or such kind of things we need to monitor. So we can here itself we can add all such kind of alerts. For now I'm going to add the like alert for application like namespace level alerts. I'm just selecting the application which I created just now, like Spring Hello, and here just we can you can see that like various like application level like error handling like events which are available. You can select the available like you can select the events for your like notification kind of things. I'm just selecting two things like on back off and service rolling update. So if anything like our application has any back off happens, it will notify me. Similarly, if I did any rolling update kind of thing like event happened, it again will notify me. So for that, I'm just adding the Slack channel. So similarly, you can add various like PagerDuty or Jenkins or all such kind of channels.
So just to add to this, before coming to the alert rules, the channels have to be defined. So you can see under the notifications, there is a notification channel where you can go and define those. It's just like how the wizards are. It's pretty straightforward to go ahead and add the channels. In case of Slack, we have to create an incoming webhook and then provide that webhook URL. And automatically, that will be added as a Slack channel.
Okay. Now let me show you the CI/CD for the Spring Boot application. For that, we have I'm just going with the quick start wizard.
Yeah, Gayatri, like you were able to build the image.
Yeah.
Is it part of it or?
Yeah, it is actually part of the our onboarding process itself. I already created one container and I put the build this is the container name and the build version. Here I have selected the output. Yeah, build output in information. Like I have selected the Docker repository. I actually created the Docker image and pushed it into the Docker hub actually. So this is
went by very fast. It went by very fast. So yeah, so it was a quick setup. Yeah.
Yeah. She has to cover so many topics. Yeah.
Now let me quickly show you the Jenkins automation. So for that, already Vinothini mentioned a couple of our GoPaddle APIs we are using as for doing the continuous deployment kind of thing. So for that, for making those API calls, we need to pass the GoPaddle API token. So first level, it will taking the GoPaddle API token. So second level, we need to specify the application information, which application we need to set up this CI/CD workflow. So we have to select accordingly. I'm just selecting our newly created Spring Hello application. Here, once I selected, then here it will show all the repository, all kind of information. So here is the thing, build on commit. Once I enabled this option, it will create a webhook in our GitHub source code project. If I'm making any code change, I'm committing it into I'm pushing the changes to my GitHub repository. It automatically again build the Docker, build the source code and generate the Docker image using the GoPaddle platform. And our Jenkins workflow will automatically update the recent image on the running application. So here itself, we can enable these vulnerabilities scan kind of things. So I'm just going with the I'm not enabling now because my base image may have it is a public OpenJDK image. It may have some vulns may detected. So I'm just avoiding this. So here we need to provide the Jenkins configuration information. Already I have provisioned one Jenkins environment. Here is the environment. Here we need to pass the information like Jenkins URL, the username, password kind of information. We have to pass it here. I'm just copying the Jenkins URL. Here we need to specify the endpoint. Then here we need to provide the Jenkins username. Then API token. For that, we just need to create the we need to create one API token for that. now next step, we need to install these two plugins in the Jenkins environment, like pipeline plugin and generic webhook trigger plugin. These are the plugins it's required to do the CI/CD workflow completed. So for my case, I already installed these plugins on my Jenkins environment. You can see that I already enabled these plugins. So if you haven't enabled, you just need to enable these plugins. Once all done, like we just need to download the Jenkins job XML file, and we just need to execute this script. Okay, now. Yeah, now it will created one Jenkins job here. So it will do the CI continuous integration and continuous delivery kind of thing. For that we need to create the Jenkins notification channel. So this will create the Jenkins notification for this particular Jenkins and the application configuration, and we need to set the alert rule also. Yeah, now it is done. Now, what I'm going to do is, now I already cloned this code in my local desktop, right? So I'm just going to make some code change here, and I'm going to push my code change. Let me check, let me show you the CI workflow instead of this message. I'm just I making the same on the test scripts also, otherwise it might fail. Okay, let me test this on my local environment. Okay, it is updated. Now let me commit this code. Here I have updated my code change. Now let me go back to our GoPaddle platform. Yeah, now you see that like one build got created, triggered, and here like our commit description, like I have the message update description and the commit ID. Like yeah, this is the latest commit ID here. So it will build, like as soon as I committed something and I pushed into my GitHub repository, it will trigger the build here. So which means it will build our recent code changes, and it will generate the Docker image for that. Like this is the image ID for S2. Once the build is completed, like it moved to created state, this Jenkins job will trigger the continuous delivery, like which means it will automatically update the our recent code change into the running application, that is like on Kubernetes. Let me take, yeah, it will take I think 1 minute. Yeah, so in the meantime, maybe let me quickly show you the marketplace. Suppose you don't suppose your application have any dependency on Cassandra or log stats kind of things. You can simply subscribe the those services from here. Like it is completely from Helm chart. So once you subscribe to this application, it will give you the visualization for the that particular application services. Say example, I'm just subscribing the Cassandra application. So it automatically it will read the Helm chart, and it based on that it will generate the all the container or deployment specs for that particular service. Under blueprints, you can yeah. Now the Cassandra got created here, and you can visualize all the services like whatever instead of viewing everything in the YAML aspect, like YAML point of view, you can visualize the things here in the form of UI UI approach. So let me check the now build got created. It should trigger the rolling update. Yeah, it actually triggers the continuous delivery, I guess. Let me check the application got updated or not. Yeah, now you can see that the service update event occurred. It actually updated our recent code change into the running running application. So let me access the yeah, the message got changed here now. So yeah, I think that's all. This is the this way you can without writing anything, you can set up the whole thing.
Yeah, one quick thing. Let's go back to the design studio. There is an alternate approach to onboarding your applications. You don't have to go one step at a time to create containers, deployment objects, blueprints, and everything. So there is something called as a modernization wizard, where you can just specify if you just navigate the step, it will automatically create all the GoPaddle resources that are required in the process. So go to the next step, you choose the registry, then you can choose the allocation policy. Now the same allocation policy will be used for building your containers and for launching the application. Go to the next step. Yeah, choose the allocation policy, and then you can choose the source control repository. So this registry or the repository for source control can be done under the settings. So you can do let's move on to that. Okay. We'll come to that later. Yeah, choose the repository. And then you can also just select the source control repository you want to use. Then choose the the repo URL, the branch, and the type of the project. And this in turn does the GPCTL the process of on creating the Docker files and the YAML files. Yeah, move on to the next. So here, as I said earlier, so you have to provide all those build, start, stop. Each one should be a self-contained script. And then finally, when you click on the next, this will get downloaded onto your local machine. Yeah, so you see where it gets downloaded, you may have to extract it and provide the location of the extracted script here. Yeah, you have to give the directory where the scripts are extracted, and that in turn will generate a command line script that you will have to execute following this. So when you execute this, this automatically creates all the resources that are required, and finally it will also deploy the application. So it's one-step process. You don't have to create GoPaddle resources one by one. But for this, the script to run, you need a Docker in your local machine, and you should be able to run this script quite seamlessly. Can you also show the Slack? I think you have configured Slack, right?
Yeah.
So let's see
Yeah,
whether
actually.
you have,
Yeah, it triggers the
so you will
message.
start getting, so you will also start getting all your notifications in Slack on what has changed, and that your team can also get instantly notified on any updates to your system. We'll stop here for a moment. Any questions?
So is GoPaddle a plugin in Backstage? Is that how it can be integrated, or you have a different-
Yeah, that's a great question. So you see the catalogs that we are creating is very different from what Backstage catalog is all about. But it can be used in conjunction, right? Today we don't have the integration, but these two tools can be used together to serve the complete set of requirements for any organization, right? We don't have a documentation, we don't have the dependency visualization and the ownership defined there, but we do have some capability called the commit. Can you go to the design studio, Gayathri? And probably you can commit and show one template.
Yeah, sure.
So mostly the catalogs that you see here are more from a Kubernetes catalogs, right? But whereas Backstage is more generic, and it is more for specifically for developers. So you see here also you can commit. Now this is slightly different from because you're not maintaining the YAMLs in in GitHub. You can commit and version control your configs here in GoPaddle natively.
So the Kubernetes YAMLs and Docker files are not committed to the repository?
Yeah, so if you're developing through this, it is not committed, but you can download and commit it. There is no lock-in per se, because the moment we start using Kubernetes, everything is standardized, right? So if you already have a YAML file through GPCTL, you can import it also and start managing through GoPaddle. So it's all finally at the end of the day, the moment it goes to Kubernetes, it's all in YAML files only, right? So there is no lock-in per se, but you can when we do the commit here, we do not commit it into GitHub. It is an internal commit system that we maintain.
Okay, so
you can in fact generate the Helm chart out of out of your blueprints. So that
you can commit also. Yeah.
Okay. So can I consider this as an alternative to Backstage to build a internal developer platform?
But it serves a different purpose. That's what I was trying to say, right? So the Backstage, it showed you the dependencies, documentation, APIs, the Swagger APIs and all those, but we don't have such integrations, right? But you need that for your developers to communicate and coordinate, right? Here,
right. I wanted a single interface for the IDP, and if I'm going to Backstage for certain functionality and for GoPaddle for certain functionality, that doesn't give a single.
Correct. Yeah. So we will have a plugin. In fact, we are on multiple marketplaces. So Backstage plugin is something that is underway. So you can add GoPaddle as a plugin into Backstage. But right now we do not have that integration. So what we are going to see next is some of the integrations and the marketplaces where you can go readily subscribe and start using GoPaddle. Probably we'll take a break and come back. I know it's a very long session. They've given us 4 hours session. So for somebody to, somebody to sit through this 4 hours, I think we need a half an hour break, break in between half an hour, right? So we shall come back again. We'll take a quick break. Is that fine with everyone?
Hey, I have some more questions. We can take now or later, whichever is.
Maybe we will come back. I think the team should be feeling overwhelming already. So let's take a break and come back and we will discuss. Okay. So 10 minutes exactly, please. Yeah. So let me know once you are done with the cluster and the cluster setup and the GoPaddle Lite installation. We will walk you through the next steps. Unfortunately, it's not letting me edit. It is for Docker desktop, it is 4.2.10. For microkate, it is 4.2.7.
I copied the version 4.2.6 from the blog. Can I cancel the installation and do it, or should I wait for the 4.2.6 to get completed?
You can do an upgrade. Gayathri, can you give the steps to upgrade from 4.2.6 to 4.2.7? You have to do a Helm upgrade, right?
Yeah, let me actually, they have installed through like using that microKTS command, right? So I think like it is quite like 2 or 3 steps, I guess.
Yeah, it's not pretty straightforward. So what you can do is you can, once it finishes, you can do a disable. You can actually go through the steps on. Okay, sorry about that.
Yeah, okay,
actually,
fine. Okay.
Yeah, you can see how to disable this. And to update the add-on, first you have to do a repo update. And then again, you have to install with 4.2.7.
Oh, okay.
Vinodini.
Yeah.
Hello.
Yeah, can you hear me?
Yeah, Vinodini. Yeah. I am trying to install GoPaddle from Docker Compose. Can you just show me the screen where I have to increase the CPU?
Yeah, can you share the
CPU memory.
Oh, yeah. So
Yeah.
one moment.
Setting.
One moment, let me show you. So under settings, under resources, you can increase the CPU and the memory. I do not know how much capacity you have. You may have a little bit challenge with this because it is not the efficient Kubernetes environment.
I have 10 GB memory.
Overall, your system itself has 10 GB? Or will you be able to allocate so much?
Yeah.
Okay, then no
Okay.
problem.
Yeah. Okay, yeah.
And then under Kubernetes, you have to enable Kubernetes and then apply and restart.
Okay, yeah.
Okay.
Thank you. Okay, yeah. Thank you.
I hope for everyone else it's going through fine. So just in case you are done with the GoPaddle installation, you can also set up a local Jenkins environment, or else we can, okay, so sharing will be an issue because the job name may be the same. So best idea would be to have installing Jenkins locally. This is the first link is for Ubuntu, and for the second one, I'm going to just about to share for Windows also. For Windows, it's going to be a lot more tedious. So for Windows alone, I think we can share the public URL which Gayathri has been using. For the Ubuntu folks, you can bring it up pretty quickly. So I've given the link from DigitalOcean on how to bring up Jenkins on your local environment. You can just follow that step. So once you're done with these two, then we'll talk about the exercise on what to do next. Yeah, so do not use this Jenkins credentials except for Karthikeyan, who is using Windows environment, right? So please try to bring up your own environment. The reason being, like if everybody creates the same container name and service name, everything will fail. So please don't use the Jenkins credentials which Gayathri has given except for Karthikeyan. Okay, anybody is through with the installation? No one has been able to complete it. Anybody is blocked? Anyone needs help? Okay, we'll take another 2 minutes and then we will go through individual setup to see if you are going the right path. Another 2 minutes, we'll just wait.
For me, it is showing like the circle is just revolving. It is just showing installing
Yes, it will take a
on
while.
Docker Compose.
Yes, it will
Okay,
take
yeah,
a while. It's because you're trying to bring up an entire platform, right? So
Right.
it's slightly heavy on a Docker desktop, but it will eventually, it'll install and it will show the plugin on the left panel.
Yeah. Okay. Yeah. Thank you.
Karthikeyan or Radhakrishnan, were you able to set it up? Do you need any help?
Sorry, I'm a little bit behind. Please go ahead.
Oh, okay. No problem. I mean, we'll have to do this together, I think, because the whole idea is just to see whether you're able to build an end-to-end pipeline, and if any of you are able to come up with the full flow, then as I pointed out earlier, whoever is able to finish the flow would actually get a $500 discount coupon, and you can use it for your setup in your for your corporate purpose also, right? So let's do this together. Let's first to set up whatever is the basic necessity, and then we will do the whole process together. Oh, okay. You're setting up Jenkins. Cool. So Karthikeyan, were you able to set it up on Windows? Did it install?
Sorry, I'm still in the Docker desktop installation. That's why I mentioned, you can probably proceed.
Oh, you're installing Docker Desktop.
Yeah.
Oh, okay. How about Girish?
Yeah, Vinothini, installation is over, but it is not displaying on the left side. I'm just trying it.
Okay. Can you, would you be interested in sharing your screen?
Okay.
You probably need some permission to share.
Yeah.
Yeah, I think I gave the permissions. You
Okay.
can, I guess.
What I need to do from my side?
You probably have to share your, are you okay to share your screen?
Yeah. What is this? Okay, I have to click on share screen.
Yeah.
Okay. Okay. Under containers, it has not come. Can you go to the images? On the left side, you see images. Let's see if it got downloaded.
Yeah.
It is
Now I
downloaded.
can see Go Paddle.
Yeah, so it is.
I need to click on start.
No need. It will automatically come up. But for some reason, in the search bar, can you search for Go Paddle? There is a search bar for the images, right? Yeah, the search bar.
Okay.
Yeah,
Okay. Yeah.
search for Go Paddle here. Okay.
This one, right?
Yeah, it has not downloaded all the images. So looks like you're having a very slow network and the images are, still getting downloaded.
Okay, it is in process, I think.
So what we can do is probably, so Gayathri, do we have that set up on your, on a VM? So the GoPaddle installation is on a VM, right?
Yeah, actually,
Would you be able to share the endpoint with Karthik? He can use that environment itself. Unfortunately, this Windows setup is going to be a little tricky.
okay, sure.
You can give that. So maybe till the end of the session, we'll keep that system on so we can, I think everybody can do a reference on that. You can share that link with the group. So Karthikeyan, you can actually use that setup. So you are having a slow network, and I think this is probably because of the Windows environment, you're facing some challenges there.
Yeah. Okay. Thanks for that.
Okay, super. So hopefully Girish is also ready. Oh, Girish is ready. Radhakrishnan, he has just stepped out. He'll be back. Karthikeyan, I hope you're done with your Jenkins setup. Oh, Karthikeyan only has stepped out. Okay, Radhakrishnan, you are able to set it up. Okay, this is for Jenkins. Or is this for what setup is this? This is for Jenkins setup. Yeah.
Hello.
Yeah.
Yeah, for Go Paddle, the website is localhost 30,003, correct?
Yeah, correct.
Okay, and it is asking for a username password, email password.
Yeah, you have to just use your email ID to subscribe, so you don't have to provide anything else. Just once you subscribe, you'll be able to access the platform.
Okay, I clicked on subscribe button, but after clicking on the subscribe,
It will show you a pop-up, and then you close the pop-up, and then it will redirect to your login page.
okay, okay. Okay,
You are breaking a bit. You're breaking a bit. So you got the installation done, right? Your installation is done, right?
I'm not able to install Jenkins.
Yeah. So Gayathri,
It's okay. We can give our like VM go like Jenkins URL. Maybe.
yeah, but what will happen if it will create
It
a
will-
unique ID?
Yeah, correct. It will generate some.
Okay, then
random
everyone.
ID.
Okay, then everyone
use.
can share the same Jenkins endpoint. So
Yeah.
Gayathri has actually shared the Jenkins endpoint. Probably you can use the same, right? For everyone, I think that same credentials and the access endpoint will be fine. It's just that, the same API key they cannot use. So you'll have to use a different API key, or I don't know if you can share it. But the same Jenkins environment will do good. So for Karthikeyan, you can access the GoPaddle VM. I mean, the credentials, you can use the public IP, which Gayathri has given. For, I think for Radhakrishnan, you have the setup ready. How about, so
Girish only we
Karthikeyan,
talked, I think.
Girish Girish will take the VM. And how about Karthikeyan? Are you back, Karthikeyan?
I think he's not.
I'm using the VM details.
Okay.
Gayathri.
Okay, now I hope everybody is then ready. So once you have the environment, okay, so what you must see, right, to make sure that the installation went through fine, right? So be it a Docker desktop or be it microKTs or wherever, GoPaddle is installed, to make sure the installation went through fine, the first thing you need to check is, if you go to environments, it should show the local cluster and it should be in running state, and you should be able to see the master version. So can you double check whether this check is done? Anybody has any discrepancies on this validation? Under environments, you should be able to see the local cluster. Work for both of you? And within the local host, if you go to add-ons, you should be able to see at least these three. You probably may see Grafana also in case of microKTs. So you need to have a kubestatemetrics node exporter and a tool server. These three plugins should be listed there. Okay, So once you have this, you should be able to see under applications, you should be able to see some discovered applications. So in case of microcatus, you will also see GoPaddle -light namespace with 22 services. And you should also be able to see GoPaddle-servers namespace. So ideally, there should be at least 4 namespaces discovered under the applications. Make sure you are able to see all those applications discovered. So let me know if you have any challenge in this particular validation so far. Okay. So if you're not able to see the applications, you go to the cluster, local cluster, and there will be a discover option. Just click on
maybe we can share the screen once.
Yeah. Would you be able to share the screen? Let's take a look.
Yeah, sure.
No, I mean, Radhakrishnan can share.
Yeah, okay.
Okay.
Yeah, let me. I don't have permission. 1 minute. Let me check. I'm not getting the option to share the screen.
Gayathri, can you enable sharing?
Actually, it isn't. I already have enabled the sharing option.
Okay.
Still, that share screen option, is it not visible?
Yeah, I'm not. Oh, okay. Yeah, got it. Okay.
Okay.
Okay. So
Yeah,
can
it
you
is
see my
actually.
screen?
Yeah. So did you? Okay, it is still discovering. You see the discover resources is still going on. It's
Okay.
in progress. So it will take some time based on your system capacity. If it's lesser CPU memory, then it probably may take time to discover.
Oh, okay. Fine. Okay.
Okay. Now, what you do not see in your environment, like you don't have the option to launch Kubernetes clusters, and you cannot build a Jenkins pipeline. At the moment, those are not available in the light edition, but I have shared the coupon code. You can go back and reuse that. It unlocks all those multi-cloud capabilities for 3 months. You see on the right-hand side, you see the launch Kubernetes option. So you will be able to use all of this with the discount coupon that I have shared. And here in the quick start, you will only see AWS and Google. I mean, AWS and Google. But if you go to directly under environments.
Okay. Environments. Okay.
Yes. If you go here, you will be able to provision all 3 cloud platforms or register anything on premise, right? So you can register it. Your system is a bit slow, I think.
Okay. Yeah.
Yeah, your system is a bit slow. Go to discover. Would you go to discover activities?
Discover. I mean,
there is a tab for discover activities, discovery activities. Yeah. View the details. Yeah, it's a pretty large environment. Looks like it's they're still discovering all the applications. So you'll have to give it a bit more time.
Yeah. Okay. Okay.
You can actually redo the same thing, or if you have a VM on AWS, the whole thing can be done with a slightly a bigger capacity. If you want to set it up for your team, you can still do that, right? You can bring up microcatus.
Yeah, currently I don't have any AWS instance with me. So.
Yeah, but in future, if you want to apply the discount coupon, you can only apply it once. So you can actually do it on your VM. Use it.
Yeah. Okay. Fine. Okay.
Okay. So let this come up. So it's actually doing the discovery. Now here is the exercise. Now you cannot build a CI/CD pipeline with this, the CD pipeline or the Jenkins workflow with this, because the light does not provide that option, right? but you can, when you use the coupon code, you can actually build it in the future. Now I have only two participants. I don't know what happened to Girish. That's fine. So now this is between you both now. Gayathri will share a container, a project. And the requirement here is that we should be able to onboard this, deploy this through GoPaddle. And if you wish to unlock, you can use the coupon code right away. And you can show a full CI/CD pipeline also, right? So this is the coupon code. You can use, so when you go to subscriptions and you see an upgrade option, you can upgrade to professional, and you can use this KCD Chennai 23 coupon code, and you will have $150 discount on that immediately, right? And then you will be able to use the full CI/CD capability. So it looks like this will need a subscription and then applying this coupon. So let's keep this aside for the time being. If you're willing to do that, you can do that. But otherwise, you should be able to build and deploy the sample application and set alerts to some notification channel. It could be Jenkins. It could be, so Gayathri, this will not work, right?
Yeah, this also will not work. It applies only the professional only.
Okay, so let's then stick only to building and deploying the application. She will share the source code repository URL. So it has some documentation on how to build and run. So once you do that, if you're able to show the running application, and you should be able to access the application outside and show the final endpoint, we will share the coupon with you. Now, if you like this whole process and if you want to share, please use at GoPaddle.io and at KCD Chennai handles while you are tweeting or sharing in your social media. So that will also help us get some, some more interest from the developer community. So we really appreciate it. So sharing is caring. So please do share and share your feedback on this. Okay. So Gayathri has shared the link. So this is the multi-port application, right? You can take this and deploy and show. Whoever does this first and whoever is able to show this deployment wins. So I'm going to stop sharing. Okay, Girish also has joined. So Girish, just for your benefit, I'm going to repeat the same thing. So Gayathri has shared a repo link. Whoever is able to take this application, onboard it onto GoPaddle, deploy it, and get the final endpoint, right? Wins. Whoever does that, finishes that first, wins. And the winning person gets a $500 on top of the $150 coupon code that we have shared.
Okay, yeah, thanks.
So this is for the professional level. So you can directly subscribe to professional and apply this. You don't have to go through the in-between subscriptions. This coupon code is for the direct professional subscription. So how do you subscribe? You actually go to subscription here, and you have to subscribe. In case of Docker desktop, it will open a pop-up. In case of microcatus, this will directly navigate to this location. This will ask for, unfortunately, we don't have the option of hiding this credit card information because that's inherently built into Stripe. So we tried our best to, make sure that we don't take any card details, but unfortunately we couldn't do it. So you can actually add the promo code, which is KCD Chennai 23, and when you apply, so this is 100% off for next 3 months, but you still have to provide the card details and subscribe, right? So you can do this later on. So if you are willing to do it right away, you can do it. Otherwise, you can do it later on as well. Okay. Okay. Yeah, I think probably would have started. Go ahead. I see one more Girish CH. I don't know if it is same. Okay, no problem. Yeah. Thank you, Radhakrishnan. Thank you. Bye. you need Docker registry to be added. So if you have Docker Hub account, you'll have to go create a API token with the read and write access. And you'll have to add it under settings for you to use the Docker registry.
Yeah, Vinodni.
Yeah, Girish. Yeah.
Yeah. Actually, it is taking a lot of time.
Yeah.
So
Okay.
I will update you, and I will do an update you by tomorrow evening.
Yeah. So whoever responds back to us gets to win.
Yeah,
So this is our email ID. Okay.
Yeah.
I'm going to share the email ID in the group chat. It's
Yes,
hello@gopaddle.io. All right. So please do share the link. If you are able to finally bring up the application, please do share a screenshot of the launched application. That is this page. Just a moment.
Sure.
We need this page for confirmation. Right. So the page where the application dashboard is available. That is this.
Okay. Yeah.
So we need a screenshot with this, all the services enlarged to make sure that everything is in running state. So we need a screenshot of this. So then we can decide. Okay.
Yeah.
Please do send me an email to hello@gopaddle.io.
Sure.
All right.
Thank
So
you.
thank you so much and have a very good weekend.
Yeah. Thank you. You both, Vinodhi and Gayathri. Good job and good session. It was a good session. I learned a lot.
Thank you, Girish.
Thank
Yeah. Karthikeyan, so you have anything to ask or shall we close the session? Okay, he moved out. Okay, we can close the session, Gayathri.
Okay, sure.
Yeah, thank you. Bye.
Bye, ma'am.